guys, this is Rydon Academia, and today we'll be looking at the polar form of complex numbers. Now, our polar form refers to a different way of presenting our complex number other than the rectangular form we have been used to. Now, this is our rectangular form, z is equal to x plus iy. Now, in our polar form, we want to express z in another method, and in this method, we'll be using our modulus and as well as our argument, okay? So now, in our polar form, our z will be equal to r times cos theta plus I sin theta. So that if you use this in solving, you will still arrive at a form like this, okay? Now, I want to prove to us how we got to the polar form. I'm going to do that quickly. Now, this is our Argand diagram, okay? This is our induced line for y, and this is x, okay? And let's say this is theta, and this is our modulus r. Now, we are trying to express x and y. We'll be using our modulus and our argument. So everything we want to do here, we want to relate modulus and arguments, okay? So now we are still using SOHCAHTOA. Now, if you look at this very, like I said, we are trying to express this using our modulus and argument. And the only formula here that relates to modulus and argument, which is the hypotenuse, is only the SO and the CA. So that's what we're going to be using. We're using the sine and the cosine, okay? So for x, to get x and r, what we need here is our cosine, the cosine of theta. So cos theta is equal to x over r. We want to make x subject of the formula, so we multiply, cross multiply, we have x is equal to r cos theta. Alright? And now let's go to y. Y is the opposite, so we'll be using the sine, okay? Opposite over the hypotenuse. So our sine theta is equal to the opposite, which is y over the hypotenuse. Now, the same way, let's make y subject of the formula. Y is equal to r sine theta. Okay? Now, like I said, our z is in this form, x plus iy. Now, our x will be replacing it with this, and our y will be replacing it with this. So, our z will be equal to x is r cos theta, and our y is r sine theta. Okay? R is common both, so we factorize. So, our z is equal to r cos theta plus sine theta. Alright? So this is how we come about our polar form. Then we introduce our imaginary number. That's why the I is there. Okay, so this is it. So with this, you solve and still get this. Now, but in this form, what we are solving with is just our theta, which is our argument, and our r, which is our modulus. Okay? So now let's use an example. Given that theta is equal to 30 degrees and r is equal to 5 centimeter, okay, we want to determine our complex number. Alright, so this is, we are given that our theta is 30 degrees and our modulus is 5 centimeter, and we are asked to determine our complex number, meaning we are asked to extract such form, okay, which we have a rectangular form. But now, what we are given here, we are going to be using our polar formula to derive our rectangular form, okay? So our polar formula is that z is equal to r cos theta plus I sin theta. Our r is given to be 5 cos 30 degrees plus our imaginary number multiplied by sin 30 degrees. Okay, that will give us 5 cos 30 degrees is 0.87 degrees approximately, plus I sin 30 equal to 0.5. Okay. This multiplied by imaginary number will now make it an imaginary value also. So let's expand quickly. This times 5 is equal to 4.35 and plus 2.5i. And with this we are now at the form where z is equal to x plus yi. Alright, and this is that. So please, we've come to the end of polar form. Don't forget to subscribe to this channel, click the notification button so that as new videos drop you are notified immediately. Partner with us, like, share our videos. Thank you very much. God bless.